Hi everyone. Today we are going to start with designing Airbnb system design. So in this video we are going to specifically talk about how we can actually make complex things easier when it comes to complex system design. Uh, I hope most of you guys must be knowing about Airbnb. So for the people who don't know, it's not nothing fancy. You must have seen ideas like this. Uh, a place, a website where one can go book hotels or personal rooms or villas or anything that is out for rented for a specific number of days from the owner. So it can be done all over the world. Cool. I think we now have an overview of what is Airbnb. Now we can actually start with the system design. So let's start with some specific questions and clarity that we need to have before starting. So you must be knowing when it comes to like Airbnb, you have one client facing sites, and then you have your like the renters. So these are the ones which provide like houses to get rent on Airbnb, and these are the ones who buy it. Now, for this sake of the example, we will do only two things. Cool. Uh, we will design the system design for Airbnb for both the host side, and for the renter side. For the renter side. Now, the only difference between both of them will be in the host side, we will be creating and deleting the listing. We will create and delete. We will create and delete. Now this will be of the houses that the hosters are putting. Now on the renter side we can actually do a lot of things. We can do browsing, uh, we can actually get listing, we can get, and we can actually reserve it. These are the three operations we can do: browse, get, and reserve. In this host we can create and delete. So yeah, simple as that. So let's also think like this. Whenever reserving is going to happen, let's say for 10 minutes, for 10 minutes, when a renter clicks book now for some 10 minutes, during which any other renter shouldn't be able to, reserve this particular house. We don't need to, worry about the what happens after reserving. This can be actually handled by a third party service of payment and everything, based on the location and available date ranges. Now, let's design this only for specifically one country, that is India. So yeah, for only one country for the sake of scaling down problems, because it will become very complex. Now, let's say in India you have how many customers? Let's say you have 50 million users. 50 million users. These are your users, and you have, let's say, total of 1 million listings. 1 million listings. Cool. So we have 50 million customers and 1 million listings. So now we have a clear idea of what we are going to do in the system design. So let's get started. So let me change the color as usual, and let's deep dive. So first, usually, just like always, we come up with a plan. So we can divide everything into two parts. As we decided, we will serve the host side, the host, then we have the renter side, the renter. Inside this also we can actually divide this plan. We can actually browse, we can actually get one particular one, and we can reserve. Yeah. Oh, okay, sorry. So this whole part is of this renter. Yeah, this of renter. And when it comes to host, we have, in that we already talked about, we can actually only create and delete. So yeah, create and delete. Simple as that. So yep, we now know plan that we are going to first cover the renter, then host, and inside renter we have three: browsing, get, and reserve. Inside host we have create or delete. Simple as that. Cool. So yeah, we can actually move. Now let's switch. Yeah. So let's, as usual, talk about the storage part. We will talk about the storage. So first and foremost, we can expect to store all of our listings in an SQL table as usual. We will have SQL table. Now, whenever a host creates or delete a listing, this SQL table will be modified. This whole SQL table will be a source base. Now, since we care about the latency of browsing listing, and browsing will require querying, because you will be querying through this only, you will be calling, and then you will be adding also to this, deleting also to this. So this is the whole source base, so we need to have a very good latency. So we can use our listing in a region called Quadtree, using Quadtree, right? You remember we talked about Quadtree, that particular storage base that is used for locations and stuff. So for speed, because this is a tree, inside that we have 4 nodes. Inside that also we can have 4 nodes. Then inside this also we have 4 nodes, and similarly the tree goes on. Cool. So I will just remove this. Yeah. So now once we know that we are going to use Quadtree, what else? Because now we know, right? So inside Quadtree we will have a index. You already know this. In Quadtree when we talk, that is known as geo index. So but we will need to make sure that we can actually fit this Quadtree in memory. So in this Quadtree we will need to store all the information about listings that needs to be displayed on the UI when our enter is browsing through a listing. So what a listing can actually have when it comes to inside a Quadtree, like we will have these nodes now. Inside this will be the listing. So what will be a listing looking like? So let's say we have listing. Yeah, so we have a listing. Inside listing we can have several things. Let's say you have the first thing that you have is title. Then you have description, and then you have images. Then you can have that particular ID. Yeah, these 4 things are I think more than enough. You have the title, description, the link to these images, and the ID. These 4 things are enough. So let's assume the images will be in sort of links, that we will be pointing the links to the images. So for this whole will take hardly, let's say 10 KB, and we have 1 million customers. Cool. So 10 KB into 1 million will be around 10 GB. It's very less. To make sure that our machines don't fail, we will have a cluster of machines, each holding an instance of our Quadtree memory, and then we can use leader election to safeguard from failures, as we have in the client server, like this. You will have multiple servers here, so if one fails, another should be there for sure for taking over. So now how are this whole solution of Quadtree will work out? Now let's look at how it is going to work. We have this geo index. So the geo index machines create the Quadtree by querying our SQL table. We will have this Quadtree. Yeah. Now then on interval of let's say 10 minutes, the geo index leader and followers all recreate the Quadtree from the table. Like suppose every 10 minutes one more thing get added, one more house get added. So it will fetch from here the Quadtree and create another node. Okay, that I need to have 4 more tables. Suppose while fetching, if the leader dies, the one that is fetching dies, one of the followers, like we talked about in leader election, will take over and continue this process, fetching from from the SQL table and maintaining this Quadtree, because this is going to be the one that we are going to display in our UI. Yeah. So yep, it was simple as that. So let's move to the next part. Let me change the color once again, and yep. So when it comes to listings, when renters browse through listings, they will have to hit some listing APIs endpoint. So the API call will search through the geoindex, right? This particular API link, whichever is going to be there, it has to be hit, and the API will call through the geoindex leaders Quadtree, because these are the geoindex, right? Suppose you live in a location name X. So suppose this is the one name X. Inside that you have multiple Quadtrees, like multiple nodes. So inside these particular nodes are going to be fetched here, right? So for this API, for relevant listing based on the location that the renter passes, we have to find the relevant locations. That should be fairly straightforward and very fast. Especially, we can estimate that a Quadtree will have a depth of approximately, let's say 10, 20, something like that. So we need to make sure that happens. So we will have to make sure that we don't return listings that are available during the date range specified by the renter that are not available. Only the ones that are available. So in order to handle this, each listing in this Quadtree will contain a list of unavailable also. Like these are unavailable. So these are not available, right? So yeah, and we can perform a simple, binary search of making sure that this happens. So we can then use paging for showing the results on the Quadtree of the Quadtree. Like you have this page, you fetch this particular data, then you can do 1, 2, 3, 3 pages, each containing the particular that these number of houses are available. Cool. So we have solved that problem of fetching and making sure that we only get the ones that are available. Now, getting individual listing, this can be a bit complex because the API call should be extremely listing. We can expect to have the IDs from the list of listing that a renter is browsing through, and we can simply query our SQL table for the listing of the given ID, right? So when suppose you choose this particular home house, and then you want to reserve it. Now this is the most important part, because these reserved listings will need to be reflected both in our Quadtree and in our SQL table, SQL table and in our Quadtree, right? So in our Quadtree, because they will have to be excluded from the list of browsable listings in our persistent storage solution, because if suppose you are reserving this should not be displayed in the tree, right? For those particular 10 minutes, it should not get displayed. So we can have a second SQL table for reservations. We can have this is this is the one that is going to be the main one. This is the one, but we can have a separate SQL table for reserve. Cool. So from here, we will be holding the list of IDs, as well as the date ranges and timestamps. So let's write what we are going to store here, right? We are going to have IDs. We are going to have the IDs. We will have date ranges, and then we will have timestamps. Cool. For when their reservation expires, right? So when a renter tries to start the booking process of a listing, the reservation table will first be checked, see if there's currently a reservation for the given listing duration for the specified date range. Cool. We will be checking that. Now following that, right to the reservation table, we synchronously update the geoindex leaders Quadtree. Like suppose this particular, I will just take an example for clearing things out. Suppose this is the Quadtree. This particular node is there. This is the leader node right now for this geoindex leader node. And suppose in this particular thing it is getting booked, right? So we are going to synchronously update the geoindex leaders Quadtree with the new reservation, right? For this particular date range. For this date range, it's not available. We will add it to the list of unavailability. We remember we were maintaining a list of unavailability to the reserved listing. So a list in our Quadtree will have some, something like this. So how will this list look like? Something, if I would like to write, it would be like this. Let's say we will have unavailable unavailable, and inside this you have the range. Let's say from this particular X date to Y date it's not available. Cool. Then it has some expiration that it will be available from here, right? Expiration that okay, from X to Y it's fine. And then simply this was one, like inside this you have one. Then similarly you can have one more range, okay, that this particular expiration, and then it will close, and this unavailable part close. So yeah, this is how things work. Like now when it comes to the load balancing part, on the host side we can actually load balance the request, to create and delete listings. So like this is the client. So this is the client. These are the load balancers. These are the clients and servers, right? So in the host side, when we want to create some changes, and these are the changes to the server, we access a list of API servers, right? So these are going to make changes to the main database. So we will have some load balancers here, and we can have a simple, these are the load balancers. We can have some simple round robin approach in charge of writing the SQL table of communicating with the geoindex reader. So on the renter side, we can actually load, balance to list, get and reserve listing across set of APIs. So yep, this API will be able to hit to the main SQL table and make changes, right? Someone want to remove or do anything, something like that, or add anything new. So yes. Now, how will the whole diagram look like, right? Just a minute. Yep. So I'll just create a whole new diagram for ease. So how is the diagram going to look like? Right? So think like this. We have some hosts here. You have one host here. You have one host here. Yep. So and you have one host here. So yeah, they will be calling to, these are the clients, right? But for now they are hosts, obviously. So this will be an API. This will be a load balancer LB, and it will be calling the API servers, right? It will be calling the API servers, and then these API servers are going to, this was when explaining this part shouldn't be hard. This was simple client server model, nothing fancy. Yeah. So when it comes to it, from these API servers, we will have some listing, right? We will have some listing of the SQL table. This is the SQL table, and then you have the Quadtree, and then these are the, it gets created using this only. So yeah, a lot of things are happening to the Quadtree. And when it comes to the clients, that are the renters. These are the renters. They are also going to talk to a load balancer here, and then that load balancer will be calling to API server that is calling API. Yeah. So what this does, the three functions, let's say three API functions we have. This is for browsing, this is for getting, and this is for reserve, and it is going to get call to all three of them, right? So yeah, this is how the whole structure will look like. So yep, these are the three functions that we talked about: browsing, reserving, getting. And these are the three API servers, like these are the servers from host side to create and delete. This is the SQL table, this is the Quadtree, and yes, everything is happening here. Inside this SQL table, you can have actually, inside this database, inside this SQL table, actually you can have two tables. Yeah, this is for reserve, and this is like for listing. This is for reserve. So yep, this is how things look like in this whole Airbnb system. So yeah, this was a high overview of how the whole design will look like. So yep, in the next video we can talk about some other design, something like Reddit API or something, and we can move to designing one API also. Yep, that was it for the video. Thank you and have a nice day.